Hi, this is Sung. I'm your online math mentor, and today what we're going to be doing is moving on and continuing on, I should say, with the work that we've been doing on mathematical induction. All right, and as you probably are aware, the three-step method that I showed you yesterday for doing mathematical induction type problems is number one, show. All right, step one is show that it's true for the first term n is equal to 1. All right. After we've shown that it's true for n is equal to 1, what we then need to do is assume. All right. Assume that it's true for n is equal to k. Now this seems like a really easy step to do, and it is a very easy step to do. All you have to do is just write a one sentence line to say that you're assuming that it's true for n is equal to k. But let me just tell you, it might be a simple step, but it's a very crucial step. In fact, this is really where the crux or the induction does take place, right? That's where the induction takes place. So it's the focal point of the induction proof, because this is where you're actually going to create our premise being, or set up the premise being true, okay, or proving it. And the third step is then to prove that it's true for n is equal to k plus 1, which is the next term. And so if it's true for 1, it's true for n is equal to k, and it's true for n is equal to k plus 1, then what we can say is it's also true for 2, 3, 4, 5, 6, etc. all positive integers of n. Does that make sense? All right. Now, we did work through series and sum type problems for mathematical induction, and we did that in the last episode. In this episode, what we're going to be doing is looking at divisibility type questions, and I've got a typical divisibility type question on the board behind me, and this will give you an idea of the sort of questions that you're going to get. All right. So the type of question you might get is prove that 5 to the power of n plus 3 is divisible by 4 for all positive integers of n, right? So like I said, there's only 3 types of problems that they could ask you. The first is a series type question, the second is a divisibility type problem, and the fourth one is an inequality type problem, okay? So this is how you basically do it. Let me run through it with you. All right, so first of all, show for n is equal to 1, all right? So basically you say, consider n is equal to 1. All right, so you've got 5 to the power of 1 plus 3 equals to 8. 8 is divisible by 4. So n is equal to 1 gives 5n plus 3 to be divisible by 4, okay? All right, so n is divisible by 8 is divisible by 4, so n is equal to 1 gives 5 to the power of n plus 3 to be divisible by 4. Does that make sense? So basically you're showing that it's true for the first term, okay, for the first term, which is n is equal to 1. So the next step is to assume that n is equal to k will also give 5 to the power of n plus 3 to be divisible by 4, okay? So in other words, assume n is equal to k, right? So assume 5 to the power of k plus 3 is divisible by 4. Does that make sense? All right. Now, the third step is basically using the assumption that we've created, we're going to try and prove that it's true for n is equal to k plus 1. So let me come around this side. All right. So we're going to consider n is equal to k plus 1. All right, so let's have a look at this. Let's see how this basically plays out. All right, so what we have here is 5 to the power of k plus 1 plus 3. Got it? So let's work this out. So you got 5 outside of 5 to the power of k plus 3. All right, so they're equal. What we're going to do is we're going to create 5 to the power of k plus 3 in there. All right, so in other words, we're gonna add 3 there, which means that we're gonna take 3 away as well, all right? But before we take 3 away, we've got to recognize that this 3 that we added, we actually add that 3 5 times because we've got the 5 out the front. So basically, we bring this 3 down here, and then we've got to take away 15. Do you see that? Because we've got to counteract the 3 that we added here, okay? Or account for the 3 that we added here. Now, because we added 3 5 times here and took away 15, this line is going to be equal to the line above. Does that make sense? All right. So now, that gives 5 to the power of 5k plus 3 minus 12, because 3 minus 15 is minus 12. Yes? Now, I want you to notice something here. 5k plus 3, is that divisible by 4? Divisible by 4? Yes. Why? Because we assumed that that would be true, okay? And we're working off that assumption. Yes? Is 12 divisible by 4? Yes, it is. Is 5 lots of any number that's divisible by 4 also going to be divisible by 4? Yes, right? And you've got one expression that's divisible by 4 minus another expression that's divisible by 4. This whole expression has to be divisible by 4. So we've just proved that it's true for n is equal to k plus 1 as well. Okay, so what we do in the next line is say this, all right? Because 5 to the power of k plus 3 and minus 12 are divisible by 4, therefore 5 lots of 5k plus 3 minus 12 will also be divisible by 4. Therefore, 5n plus 3 will be divisible by 4 for all positive integers of n. Does that make sense? Because if it's true for n is equal to k plus 1, and it's true for n is equal to k, and it's also true for n is equal to 1, then it's true for 1, it's also true for 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc. Does that make sense? So that is how we do a divisibility type mathematical induction problem. Let me stand aside so you can take that all in, but thank you very much for watching.